determine whether the integral is convergent or divergent. Evaluate if convergent. The integral from 0 to infinity, 1 divided by the fourth root of x plus 1 dx. Notice that this is an improper integral, and we can see that quickly because we have an infinite limit of integration. So this tells us that we're going to have to use the definition of an improper integral with an infinite limit of integration. So this integral is equal to, by definition, the limit as b goes to infinity, the integral from 0 to b, 1 over the fourth root x plus 1 dx. This integral at this point now has finite limits of integration. We take b to be finite, and so we can apply the fundamental theorem of calculus. So let's go over on the side maybe and just integrate that out, figure out what that should be. So the integral from 0 to b, 1 divided by the fourth root x plus 1 dx. We can rewrite the integrand as x plus 1 to the negative 1/4. Remember, the fourth root is the same as the 1/4 power, and then since this fourth root is in the denominator, that makes the power negative. Now we can do a small substitution. Let u be equal to x plus 1. du is actually equal to just dx this time, which is nice. So the integral really ends up being the integral over the new limits of integration, whatever those may be, u to the negative 1/4 du. And if we find an antiderivative, we do that by the power rule in reverse. So add 1 to that power. Negative 1/3 plus 1 would be 2/3. And we have to divide by that same number. The fundamental theorem says that you then evaluate that at your endpoints of the interval. Finally, dividing by 2/3 is the same as multiplying by 3/2, and u is equal to x plus 1. So this is 3/2 x plus 1 to the 2/3. Now that we're back to x's, we can go back to our original limits of integration, 0 to b. So if we take that back over to our improper integral, we have the limit as b goes to infinity of 3/2 x plus 1 to the 2/3 from 0 to b. Recall that this means you plug in the b first. The upper limit of integration always gets plugged in first. So 3/2 b plus 1 the 2/3 power. The 2/3 power means the cube root squared minus then 3/2 0 plus 1. And again, it's the cube root squared. That's what the 2/3 power tells us. The 3 in the denominator says it's the cube root, and the square tells us it's the square. Okay, then we can try to simplify some of this. Notice that 0 plus 1 is 1. The cube root of 1 is 1. 1 squared is 1. So when you multiply that by 3/2, you simply get 3/2. So this is really the limit as b goes to infinity, 3/2 the cube root of b plus 1 squared minus 3/2. Taking the limit then, of course the limit of negative 3/2 is just going to be negative 3/2. That's a constant. But the limit of this other guy, notice that as b gets larger and larger and larger, the cube root also gets larger. And then when you square that, you get larger still. Multiplying by 3/2 still large. So as b gets bigger and bigger and bigger, this whole term tends to go towards infinity. Tends to infinity. So this is infinity, and when you subtract 3/2, you're left with infinity. This tells us that the limit, and hence the improper integral, diverges. So the integral from 0 to infinity, 1 over the 4th root of x plus 1 dx diverges.